In 7.5 billion years, we'll be absorbed by the sun, but a lot can happen until then. In fact, in merely 1,000 million years, our planet will be simply unrecognizable. Here at the Hub, we're not fortune tellers, but we've looked deep into the rocky record of our planet's history to find the most surprising things that will happen to Earth in a billion years. The many canyons, mountains, and valleys are like cracks in the Earth's hand, and we're reading the palm to know exactly where the next billion years will take us. While you're watching, click on the subscribe button. It's like a big red breaking news alert. The Hub will keep on giving you the latest info millions of years in advance. Good night, Moon. The Earth as we know it is going through some big life changes, and it won't be the same after this. But the Moon's going to be there for us, right? Wrong. Thanks to tidal acceleration, the Moon is moving away from us. With each passing revolution, the Moon is spinning slower and slower with an expanding orbit. Eventually, the distance of the Moon will throw our poles totally out of whack and later make the Earth tidally locked to the Sun, halting planetary rotation. Thankfully, that won't happen for several more billion years. In the next billion years, however, we'll merely have to look forward to the complete disappearance of solar eclipses. The Moon is 400 times smaller than the Sun, but the Sun is 400 times further away, which is why they appear to be the same size in our sky. The further away the Moon gets from our planet, the smaller it appears. Eventually, it'll be unable to cover the Sun when it passes directly overhead. Sadly, after providing eons of cosmic enjoyment, the Moon will only be good for a lunar eclipse. Shrinking carbon footprint. A big deal is being made of climate change and its potential long-lasting impacts. Caused by the overabundance of greenhouse gases in our atmosphere, it's contributed to the warming of our planet, the melting of our ice caps, and the unpredictable weather patterns we've lately been experiencing. And yet, as our volcanic activity is expected to slow over the next billion years, our planet's knack for rejuvenation will lead to the expulsion of carbon dioxide from the atmosphere. Unfortunately, life needs a healthy level of CO2 in order to survive. With the planet's cleansing of carbon dioxide, many of the carbon-based life forms inhabiting our planet will face extinction. At 600 million years in the future, C3 photosynthesis, one of the 3 types of photosynthesis found in the current plant life, will be obsolete. Without volcanoes, the 99% of plant life relying on the C3 process will cease to exist. 200 million years later, C4 photosynthesis will phase out, and shortly after the billion-year mark, all eukaryotic life forms will die of carbon dioxide starvation. That characteristic covers quite a wide swath of Earth's organisms. So go to your nearest volcano and give it a hug. Who knew these exploding mountains were so essential to our survival? Supervolcanoes. With all these forces pushing and pulling at our crust, supervolcanoes will find ways to emerge. Volcanoes act as vents for the super hot inner workings of our planet, but every once in a while, the pressure builds up and becomes so intense that the crust cannot withhold the massive concentration of magma, making a supervolcano burst forth. Probably only a couple 100,000 years from now, a supervolcano will erupt, shooting out 250 cubic miles of lava and Earth-encompassing plumes of ash. An additional supervolcano is statistically expected to erupt nearly 2,000 cubic miles of lava shortly after that. That monumental amount of hot lava is nearly equivalent to the volume of Lake Erie. Around this time, Hawaii's newest volcano is expected to form an additional island before all of Hawaii is expected to sink into the depths of the Pacific Ocean in another 79 million years after that. But with the change in the magnetic forces at play within the Earth's interior, the center of the planet will start to cool down. Volcanic activity should slow, and carbon dioxide levels will eventually fall by the billion-year mark. Galactic birthday. As Earth continues to migrate around the Sun, our days get slightly longer. But keep in mind, the changes are minute. Every 100 years, 2 milliseconds gets added to the clock. So, in 200 million years from now, we'll have days on Earth that last 25 hours. To calculate this down to the millisecond, scientists analyze historical astrology records and star charts, comparing the accounts and dates to pinpoint the way our days evolved over the years. As for galactic years, it takes 250 million Earth years for our solar system to revolve around the center of our galaxy. In a billion years from now, our Milky Way will only be 4 galactic years old. You can calculate the galactic year by considering the speed at which the solar system shoots around the galaxy at 135 miles per second, and the fact that it's believed to be 27,000 light-years away from the Milky Way's center. As we pass other stars spinning through space, they have the potential to slingshot icy comets at us with their passing gravitational force. While we orbit from within the same galaxy, there's always a chance our paths will collide. Moving and shaking plates. On average, the tectonic plates move approximately 2.5 centimeters per year. That doesn't sound like much, but the bumping and grinding of these plates will reshape the Earth's entire exterior. Once upon a time, North and South America, Africa, Europe, Asia, Australia, and Antarctica were all merged into one giant supercontinent, Pangaea. That's likely to happen again, but first, there's going to be some nips and tucks to each individual landmass gliding across the crust. Africa, in particular, will take a lot of abuse. First, in 10 million years, East Africa will clip off from the mainland continent as if part of some kind of real estate scheme plotted by Lex Luthor. An ocean will begin to form in the space between, and then northern Africa will ram into southern Europe in 50 million years, closing up the Mediterranean for good. It stinks for the Grecian coastline, but it'll shorten the commute time between Rome and Cairo. As North America collides with Europe and Africa, it's predicted that a mountain range will form at the meeting point between the continents, with the size rivaling the Himalayas. And then the continents will separate again before we even hit the billion-year mark. Stars' turns. Since the start of civilization, humankind looked to the stars to tell the story of creation and predict the future. Navigators used the locations of these celestial lights to guide their journeys. But in a billion years, no stars will be where we know them to be. The Big Dipper, Orion's Belt, Taurus, and any other zodiac sign you can think of will be unrecognizable. As these thousands of distant suns take new places in the night, massive space events will likely create different displays for any viewers sitting on the surface of the planet. Over the next billion years, many stars will transform into giants or dwarfs, depending on their age. Nearby supernovas will pop into the night sky, creating large light shows covering much of the field of vision. In 500 million years, an interstellar burst is expected to be so powerful that it will bathe the planet in gamma radiation. Whoever is left on Earth at that time will hopefully gain the same powers that make the Fantastic Four, well, fantastic. But more likely, this wave of radiation is likely to leave a mark, unfortunately causing mass extinctions to many species inhabiting the Earth. Shifting axis. Earth's moons shifted off its axis 3 billion years ago, and that had tremendous consequences for the water that was once frozen to its surface. Like a wobbly top, the unsteady movement on its axis caused the surface ice to wrench free and drift into space. A similar event could happen to Earth over time. Yes, Earth's poles have shifted, and they actually still move to this day. The axis is known to alter its location by about 30 feet every 100 years. Poles have been moving westward since the last ice age, as melting ice helped redistribute the planet's mass on a grand scale. Since 2000, however, the North Pole has started to move to the east. Due to drier conditions in Europe and the melting of the Greenland ice sheet, a quicker than previously expected redistribution of planetary masses is occurring. When oceans have melted millions of years from now, imagine how drastically that weight loss will change magnetic planets running through our rocks. In a billion years, our poles will likely have swapped places, and Earth's axis will probably move to a totally new spot. 1.3 billion years after that, though, Earth's magnetic field is expected to shut off entirely. Always sunny. Thanks to a 10% uptick of the sun's rays, we'll see a rise in temperatures growing higher as the land dries. 10% doesn't seem like a lot, but it's enough to keep it always sunny in Philadelphia. And everywhere else, for that matter. Assuming the oceans don't disappear in a great solar wind gust, they'll evaporate into our atmosphere at an ever-quickening rate. The more the water vaporizes into our atmosphere, the faster the evaporation process becomes. Imagine a day's weather report calling for 1,000% humidity and counting. This monster greenhouse effect causes the atmosphere to absorb more sunlight and continue to drain the surface of more water until there's not a drop left. The brightness of our parent star has increased by 1/10 every billion years, and we've gone from a lifeless ice ball to the temperate sphere we know today. With the sun's increase in luminosity, Earth will finally become uninhabitable, with few possible exceptions. Ironically, at this time, Mars will probably become habitable once again. With a warmer sun, it could become a giver of life to the red and currently dead planet. If this next billion years are ours to shine, the next billion years belong to our red neighbor. Water everywhere. The oceans and the seas cover 75% of our planet, But by the time we reach this distant future, we could be fully dried up. Over the next several million years, if we're able to curb our current pollution trends, the acidification of our oceans could slow to a halt. Thanks to greenhouse gases currently flowing through our atmosphere, the Earth's waters are absorbing CO2 at an alarming rate, causing once neutral oceans to become acidic, hurting sea life and bleaching life-giving coral reefs. Yet in 2 million years, our ocean's natural cleaning process could purify itself like a Brita filter on steroids. Unfortunately, other elements at play would ultimately evaporate most of the H2O on our world. Yes, Earth's all-consuming oceans will have dried up. Under this theory, small lakes and ponds in the North and South Poles would be all that remain, and in those little pools will be the last vestiges of simple carbon-based life. Tiny organisms with far less complexity than the animals we interact with every day and see in the zoos or on television. In that way, Earth will be just like Mars, which once had an ocean covering much of its northern half, before a gust of solar winds blew it off the planet. Goodbye, canyons. If you were to set foot on the terrain of your homeworld after a billion-year absence, you'd find an unrecognizable alien landscape. The first thing you'll notice, or not notice, is any familiar landmark. Assuming we've moved off the planet anytime in the near future, all current man-made structures are expected to disappear in give or take 1,000 years from now. Yes, even the Statue of Liberty will have ceased to exist. Spoiler alert for all you original Planet of the Apes fans out there. But the naturally rocky structures etched into our planet's land by running waters and passing glaciers will also have changed entirely. Thanks to the ever-running waters of the Niagara River, for instance, Niagara Falls will slowly disappear. The Horseshoe Falls portion of this natural wonder will shrink. Eventually, the uttermost section of the falls will dry up and cliff faces will flatten, making it all part of nearby Lake Erie. The Rockies will also have long become a flatland by this time, and the Grand Canyon will have deepened and widened around the Colorado River. However, the unpredictability of massive volcanic activity and great movement of the tectonic plates will create massive new mountain ranges that could eclipse the many rocky features of the Earth we see today. In the distant future, humanity may have traveled at light speeds to explore different galaxies, settled in the orbits of alien stars, and evolved into new and powerful beings. But we'll always carry the genetic blueprint forged from chemicals on the third planet of this solar system. No matter how drastically different Earth becomes, it will always be our unique and ever-changing birthplace. So join the Hub as we toast its 4.5 billionth birthday and celebrate another billion years onward.